methodology to it. We can get into this.
Yes.
It's better with slides and visuals and explaining it. But there's like Netflix sort of made the practice popular because Netflix has the reality that they absorb 38% of the entire internet is Netflix, right? Not only the internet, but Amazon Web Services. They had the reality of Amazon breaking below them, right? So they said is, okay, we're not going to just tolerate this because every time we go down, right, like we lose customers, right? So they said we're going to build our systems to respond, right, to these scenarios, right? We're going to proactively break our system on purpose, right, to determine where the weaknesses are and determine that our methodologies for resilience actually work, right?
Monkey?
Chaos Monkey.
Yeah,
okay.
It's
Chaos
a whole,
Monkey was a very
the
popular.
first one. Yeah, and it had Gorilla and the other ones as well. But all right, so
yeah,
let's get started. I sent you the link.
Okay. Oh, sorry.
Go ahead and join.
I'm
While
sorry.
you're getting on, I'm going to BS for a minute so that we can,
Sweet.
because the thing already started. All right, so today we're going to be talking to Aaron, which we've already started. Sorry for everyone that's online, just came and joined us, about security and DevOps. Before we get started, wait, we don't even have pizza. Like, what is going on there?
Well, he said his meeting was going till noon, and then he could go get the pizza.
Oh, crap. All right, so this is a perfect example. We need help. Right? So you guys want to have food on time, not cold. We have no microwave.
Everybody see me?
Okay.
I'm on.
You're on? All right,
We're going to have a sound now.
Yeah, so we'll figure out the sound thing in a minute. So please, by all means, help out if you can. I'm probably going to be taking on a role very shortly, which means I'm going to have very little time, which means that this group is going to continue. We're going to actually need people to help. More than willing, we can get up and have a main person out, help that person out. We can do it all type of ways, but I don't want it to die because I'm no longer like the one cheering and organizing and doing all the other things, right? So please consider that. All right.
We lost both sides.
No, you're fine because it's on his, but I just want to show this really quickly until we get going. Quick story too as well. So this dev group started about 4 years ago, but actually Aaron's the one that inspired the group. We met. How long ago was that?
4 years ago.
That was more. It was longer than that.
No, actually, no way. It was longer than that.
Yeah, it was many moons ago. We were on the same hallway. We were talking, you know, that sort of thing. I didn't realize that I did any dev work. I didn't realize I was doing. Like, hey, this is crazy. We have a community.
It's like after like a year.
Yeah, exactly. Yeah, we talked for a long time, not realizing each other. And it's like, this is crazy. We should have a community. It's like, yeah, we should do that. And he left and went on to Green Pastures. And eventually, we got this group started. So if you do enjoy the group, then also give them thanks, not just for today's presentation, but for inspiring.
You give me way too much credit here, but I love it.
Yeah, that's how we do. We butter up our today's thing is going to be again on the road to DevOps. Road to DevOps. Chaos engineering, honestly, he has really good at getting titles.
Gotta have cool titles.
Yeah. So we have a number of things that I mentioned before in the backlog. There's 46 items in the backlog. There's 6 that are being planned, including we're going to do. I'm not sure if you guys are aware of it, but maybe 2 years ago, a year ago, we did a whole series on Git, like an introduction, an intermediate, and advanced. We're going to do that again. I have to do this for my contract on Monday, so since I'm learning all over again, we'll just slide in schedule. We'll schedule a single thing, or one of the ones that we do when our speaker drops off last minute. Another one in there is the continuous growth. Are you learning? You know, do you have 20 years experience? Do you have 1 year experience 20 times? 2 different things. How can you incorporate that into your manager, your company, and your whatever doesn't really support you growing? How can you still actually grow? And what the responsibilities are for you versus what the responsibilities are for your company or your employer. Those are 2 different things. So with that, I'm going to turn it over to Aaron. Hopefully we won't have any crazy echoes. I'm going to try to set this up, and then we'll find out what's going on with our pizza and our.
Yeah, use some water for sure.
Yeah, definitely.
You want to hit the vending machine?
Yeah, I'll get it. But
Promise I'll pay it back. Promise.
all right, are you hooked up?
Oh, no, I'm ready to
Yeah, go ahead.
get it in. Get it in. All right. Oh, this is weird to show myself. Okay. Okay.
Whatever you want to do.
Cool. Okay, so this is me. I've got a couple different decks. I've got. By a queen.
No,
Echo. But it's not.
it's not you. It's me.
Not you, it's me.
Yeah, you're good to go.
We're good now?
Yeah.
Okay, no echo. Yeah, so this is me, Aaron Rinehart. That's my contact info. Please, I'll have it up again, but like, I live here in DC, right? So you guys want to have lunch, coffee, if anything I say is crazy, which I probably will say a lot of crazy things. I used to work here. Actually, Goddard is like my out here. I actually still have Christmas and Thanksgiving with a lot of people I used to work with at Goddard. When I moved out here, I didn't have a family here, any friends that lived here. Goddard became my home, right? So I'm very much feels like coming here. But since I left Goddard, I don't remember, like 5-6 years ago, something like that. Whatever, 4 or 5 years. It seems longer than what it probably was. But please gather my contact information. I'm open to talking about this stuff. I know government security practices really well. Also, if you want to talk about how you make the road between some of the things I talk about, private industry, we have a different focus, right? Meaning that, and I've noticed this, I do a lot of speaking in DC, and I do a lot of speaking side by side with other government folks for different challenges. But the reality is that for UnitedHealth Group, for example, we don't innovate. We like to be more efficient, and profit is driven. Our shareholders want a profit, expect a profit. In fact, we tell them ahead of time it's coming, right? So we got to make it, right? So I'm a Twitter addict. So if you just want to hit me up on Twitter, it's like texting me. So over here you see, so John Willis, I don't know if you see that. Maybe it's better over here. So John Willis is not sitting on my lap. So John, if you don't know much, if you don't know John Willis is one of the authors of the DevOps Handbook. That's Jez Humble, who's one of the other authors. It's Gene Kim, Jez Humble, and John Willis. He's not sitting on my lap. He's just the Jeff Williams, the founder of OWASP, which is an open web application security project. Is like 7 foot tall. So that's my beautiful family. And then that's the inside engineering team at Netflix. On the left, Nora Jones, who's kind of blocked out, is she guys went to that or saw Amazon. Amazon does a conference every year in Vegas. She keynoted it on chaos engineering. I did a project with them on. I'm actually consulting to Netflix, the people who made chaos engineering popular, on how to do chaos engineering for security. I was the first ever to do that. So like it's more of a cultural problem than an engineering one, because the security industry, it's different it's just a bird. It's not as easily not an easy bridge to cross. And we can talk about that. So yeah, go ahead.
It's not easy to show ROI.
Yeah, right, yeah.
You're on only when things go bad, dude. That need to wake up.
When there's a data breach, the funds come, right? Yeah. So like, who's the UnitedHealth Group? Oh yeah. So I guess I could actually put this in present mode. That'd be easier. Yeah.
Those are online.
Oh, yeah. I can right now or later.
Whenever you feel.
Oh, I'm not sharing it now.
Yeah.
Oh. Okay. Shoot. Sorry, everyone. So I'll go back to see lovely pictures of me. Oh, I see you.
Yeah, you don't want to see me. That's not what you want.
Yeah, I see you. Share. Oh, I share my screen, right?
Yep.
I am screen sharing now.
Yep.
I got a couple different decks I'm going to go back and forth on. I'm willing to send these out later if anyone wants them. One of the decks I might have to scrub because it's actually my RSA. I'm speaking twice at RSA this year. It's actually one of my decks, right? Is the Road from Rugged to Chaos. And what that really the underlying theme there is failure, about the understanding of human factors in failure in engineering. We all make mistakes. Like that's really what chaos engineering is about, right? It's about understanding that we're humans make failure. Anytime we update, we push code, like even when we automate code, right? You're just automating the failure, right? Humans, anytime we test something, there's opportunity for failure. So you can either anticipate or instrument that for that failure or drift into the unknown. There's a great paper we can talk, I'll get into it in a little bit from Sidney Dekker, who wrote Drifting into Failure. He's a professor at the University of Sydney. And I can give you that information later, but it's a great concept. It's a great academic paper on human factors and how they relate to engineering. I'm sure that's probably a reality for a lot of folks at NASA. The folks that didn't see my slide, Joey, this is me. Okay, moving on. And I can share my contact info, and Andre certainly has it. So who's UnitedHealth Group? Well, we're not UnitedHealth Care. Okay, we are, but like when people think UnitedHealth Group, they're thinking UnitedHealth Care, right? Because that's your normal interface for people. We're actually about 400 companies, large. We acquire 40 companies a year, 30 to 40, roughly. And some integrate, some don't, due to whether they previously worked with our competitors or industry or regulatory issues that have to keep the company separate. So complexity, like you've never seen. I know NASA, and especially Goddard, is very similar to a technology diversity perspective. It's like the United Nations of technology. You've got everything, right? We're the same way, right? Exactly the same way. We are so large. We are the largest healthcare company in the world. That's private healthcare company in the world. The only two entities that are larger are public, which is HHS in the United States and NHS in Britain. Security is about 1,000 people strong. We have 8 to 9,000 applications that are actively supported. We have every compliance framework you ever could possibly think of, including FISMA, including DR, which is popular, coming up here, right? Next week is going to be implemented. The New York cyber law, which is another very complicated one. We have roughly 28, depends on how you account for what companies we bought, but 28,000 to about 40, somewhere in between there, developers. Everything from .NET, Java, COBOL. 60% of our data still runs on mainframe. I know there's mainframe still here at NASA. We have that same problem, but actually, I think mainframe's sexy and here to stay, right? Because mainframe's actually super expensive to convert, right? You can convert a mainframe application over to Java, but that stuff still runs and it runs well, right? So yeah, I already explained that. We are waterfall, agile, and others, partly because of our acquisition strategy. We buy companies that are super Silicon Valley. We buy companies that are also like, really, that's your technology? Kind of like, pure in their practices. Like I said, we're all around the world, from Australia to all over Europe, South America. So that's a little bit about the problem set. What I'm going to cover today is a lot of stuff. But what I would like to do, since it's intimate, I don't know how many people we have online.
Like 9 right now.
Okay, so for the folks online, is there a chat? Is there a chat going?
Yeah.
So let's catalog like questions as we go, or things you want me to cover, talk about. So just post it out there in the chat, and we can make sure we cover that. As long as somebody can monitor that, it'd be you. We monitor the chat log. We have my expertise lies predominantly in the field of security, and software security. My job as the Chief Enterprise Security Architect is I am a senior leader in UnitedHealth Group in that space. My job is design. My job is to move the program forward. I used to be in a position where I managed all of architecture. Now it's sort of, if you guys are familiar with like the role of a distinguished engineer, if you're familiar with that kind of track of that, that's really what my role kind of is to take on challenging problems for the company and that sort of thing. So areas I can cover, and I think Andre would like requested for me to cover things like containers. We'll talk about container design. I covered rugged DevOps. I really think from some of the lady in the back brought up software security throughout the life cycle, I got some really interesting things I think you might like there from some open source tooling perspective. I am a very objective-oriented engineering professional. I believe in objective data, not subjective process, meaning objective data does not lie, does not have a political angle, right? Feedback loops, right? The concept of feedback loops, what DevOps is all about. So like, so I can cover anything from rugged DevOps, DevOps in general, security tooling, open source, how to create an open source project at NASA. I don't know, you guys have open source projects, right?
Yes, but there's a big process to get to it from code that's developed to the outside world, and it takes months.
It does?
Yeah, it's a work in progress.
What about InterSource? I notice you have GitHub Enterprise, right? Do you have like some InterSource initiatives going on?
Yeah. That is also a work in progress.
Okay.
The other thing that you mentioned is every time you do a major rev of the software, you have to go through the process all over again.
Oh, you mean for open source?
Yeah.
Even though you've open sourced it?
Yeah.
Doesn't make any sense.
It's bullshit.
Yeah. The licenses is Apache? Apache too?
I mean, NASA has its own open source license.
Oh, okay.
So you can online take a look at it. It's kind of bullshit.
Okay.
But, the process is that even though they give a lot of lip service to, we want to open source things and provide to the community, blah blah blah. Internally, their processes, legal and otherwise, basically inhibit that from actually happening.
We got a lot of ITAR and EA architects that we got to look out for.
Well, it's not even that. It's just that, like, if you go to the lawyers here, their first response to everything is no. So,
well, partly that's the government in general, though. I mean, like you're dealing with, like NASA is dealing with the lack of the government evolving to the modern age, right? Like everything from employment practices and payment. I guess we won't get into that, right? Like the Silicon Valley pay scales are just, hard to compete with. You know what I mean?
So one last thing, which is because
sure.
It's every major rev, you have to go through the whole process again. You end up doing minor revs that are actually major revs. You just
Working system.
But that's the thing. That's so like that's a great underlying cultural problem, right? That you just called out there, right? If like we need to make the right thing to do, the easy thing to do, right? Like it's not that hard because you know what? Because what happens is the wrong thing becomes the easy thing to do, and people do the wrong thing. They find all kinds of ways around it because you know what? Your job is dependent upon it, right? Software engineers, I inherently, a lot of the security community will point the finger at software engineering in that, they intentionally want to railroad and mess things up and do things insecurely. I have been a software engineer, and I never want to do anything intentionally the wrong way. I just may not have known, right? Or I may not have had a solution. Secrets management is always a great example of that, right? Is that I ran into that issue at several companies, is that the software engineering community wanted a secrets management tool, but they didn't have one, so they just put them in text files and in code, directly into code, right? Because they didn't have a way to do it appropriately. Anyway, so let me open up my other slide here, because this is my chaos engineering deck. Let me open up this one. This is more RSA-ish. Sorry, guys. It's kind of, oops. Yeah, here we go. It's coming.
You have to reshare it?
Oh, it's just me. I'm doing it from Google.
Okay.
I guess what I can, if there's even, I already have some feedback on software engineering lifecycle security within that. I think that's where I'll start. The other things you guys want me to cover, is chaos engineering something you guys want me to touch on?
Yes, I've never heard this term before.
Awesome. No, I love.
Yeah.
We could definitely talk about it and go in depth on that. So chaos engineering.
Do you use domain driven design
for microservices?
Yeah, well,
APIs?
Keeping things secured, is that your approach to it?
I can touch on that. Yeah, we can touch on that.
Well, that would go into that life cycle.
Are you a Martin Fowler fan? He's big on domain-driven design.
I got one for you. Difference between security and compliance.
Oh yeah, definitely. Let's do that. Let's do that.
I can be totally I am totally a secure thing.
Oh yeah, for sure.
So
For
we'll
sure.
do soft eng security chaos and DDD D3.
Or alternatives.
You know what? One thing I think I will cover too. How many people are familiar truly with distributed systems in the modern era?
We do.
No, not, I'm never actually would be writing distributed systems.
Okay,
Yeah,
right,
so,
like-
yeah.
but like this is the reason. But understanding of distributed systems is the reason why chaos engineering is very important.
Fine.
Right? It's the way modern applications are being designed, right? And what's happening is we're no longer able to really understand what our applications are doing because of it, right? And I'll explain that problem is that things like continuous delivery, right? You got companies like Google that can deliver 20, 30 times a day for a single app, right? But magnify that. Like let's say Google for one application may have 10 APIs. Those 10 APIs are being updated 20, 30 times a day each, right? Those 10 APIs may be using something like blue-green deployments or canary deployments or A/B testing, where they have, instead of just one version of API A, they have 6 of the version magnified by 10. So 60 of that API are running at one given point in time, right? So 60 times 10, you have 600 potential microservices running at a given point in time. You understand what I'm saying?
But no, but not everybody's actually hitting against that because
Exactly.
it's a select few.
And that's why the canary deployments, the blue-green deployments work, is only certain populations are using certain versions, and you're doing testing on the other versions that are spun up, right? But the advent of a lot of these newer technologies like immutable infrastructure as code, the cloud, microservices dominated architecture, you now have these things you're just spinning, all these places spinning at the same time. Not to mention, you have external APIs now, right? Like we have Department of Health and Human Services, we've got Wells Fargo, we've got Bank of America. You've got all those APIs. You don't even know what the heck's happened to those things, right? The iteration, those things are changing all the time, right? So like, how is it possible from day 1 to day N to know what's going on? Like, so I can talk about that problem, but that's also why new advents and news of instrumentation are being developed, like chaos engineering. So I will start. I'm going to start like by. Okay. I'm going to start by. That's okay. No, I really can. I wish I had the whiteboard and like.
Oh, here, we can take.
Can I present here on these things and
Yeah.
not here?
Yeah.
Hold on. I think some of this stuff would stick a little easier if I drew it, right? So, and I can move the camera there, like that. And we can clean this up. We'll put the lights on. Yeah, it's good. Perfect.
Yeah,
I can.
Can you turn off the projector?
Trying to do that without turning off
Was
everything.
that Terraform I saw? You guys, anybody HashiCorp fans? No? No HashiCorp fans? Okay. By the way, if I say anything that's crazy, right, and we don't have time to cover it, like I said, you can contact me and we can have lunch. I can come out here and talk about it, lunch or something. As long as we don't let you lunch around Goddard. I'm just kidding. I made that mistake before. So let's talk about how we can improve software. Let's talk about product, right? Products and service delivery from a software engineering perspective, and how security can help drive velocity in that process, right? We always talk about, probably to you guys, from what I remember, it's probably similar, maybe it's evolved, but you guys would just see it as a barrier, right? So many barriers, right? Like, security is just that bottleneck. It's that no. It's that like you can't do that. You can't do that. You can't do that. But really, serving and drive velocity and delivery. And one of the ways I did that was I found this really cool project. So this is James Wickett. I do a lot of speaking with him. Like he invented this tool called Gauntlet. It's open source, right? What it allows you to do is package in security testing tools that are open source, right, and put in your pipeline. So let's talk about like the software delivery. Let's talk about delivery. Let's use black. It's easier for people to. I'm assuming that this one works too. Well, it's not permanent, is it?
Go for it. Then you can vote.
Okay, all right.
That's my vote.
Delivery.
Puts a permanent marker next to a whiteboard.
Right. Jerk, right? So delivery, right? If you're on waterfall, or you're on sort of legacy, you could even be pseudo agile and solve this problem, right? A lot of what happens is you have these 6 months at best delivery cycles for versions, right? This is not good engineering practices, right? So like that's what we realized, right, with DevOps and Lean and Gold Rat in the anybody with the Phoenix project? Read it? Okay, cool. So like what happens is that you're building, like there's all these different handoffs, different stops and gates called gates throughout the delivery cycle to 6 months, right? And what happens is security may be pseudo consulted, right, in different parts of this, right? Usually to tell you can't do something, right? This is what it seems like, right? Well, the problem comes into from a software engineering perspective. One of the major problems is that the testing phase is here. Usually, you may be doing your smoke tests. I mean, like the software engineering community in general may be doing smoke tests, end user acceptance testing, maybe doing UX testing, insert your testing, software engineering testing technology capability. But the problem is that security is always here, right? Is that what happens, but what creates the problem here, this is where it's saving, this is where this little project, the UnitedHealth Group, tens of millions of dollars, okay? What happened was because even when we got into Agile, what happened was that we were still kind of doing this monthly or this time-based scanning or like, let me cover the problem first, right? The problem is when you get here, you do your scan, right? That could be anything from a static code analysis to dynamic, which is runtime, when the application is running, test, dynamic testing, insert other tests here, right? So this happens like Web Inspect 4 to 5, Foundstone, App Inspect, Acunetics. You guys have one of those, I'm sure, right? So this happens here. The problem is that when you were developing, you were creating problems. You didn't know it, right? You were just trying to do your job, right? You were trying to develop good code because honestly, who gives a crap if it's secure if it doesn't work, right? So like you're trying to achieve the mission, but you had to wait till the end of when you were done, 6 months later, 3 months later, whatever, find out you failed. You created failure, right? And when you get here, it's kind of embarrassing a little bit, like that. Like security committee comes and says, "Man, look at your poor code." Right? It's public humility in a way, right? So like the problem is that not just the problem is not just scanning. It's scanning plus when you're done scanning, you get the results. Oops. You're gonna fix, right? You fix. You go here. And you go here. Then what do you got to do again? Scan again, right? Right? And then what do you got to do? Remediate. And then fix, right? And then scan. It's just scan, fix, scan, fix. This could add 3 to 6 more months on top of it. I mean, probably not 6, but probably more like the 3-month timeline, right? Like this is not fair to the software engineering community, right? So things like DevOps, right, in Agile, introduce the concept really of just shifting work left, right? In doing things in small iterative batches, right? So what we did with Gauntlet is that we were doing this testing at the end, right? It's horribly inefficient as well, right? So not only is the scan, fix, remediate, scan, vicious cycle a problem, it's also a problem in how that's done, right? So developers do not want, I as a developer do not want a PDF file, right? Put it in Jira, right? Put it in my defect management system so I can properly align that fix into my delivery cycle when it's appropriate, right? Like, and prioritize as needed, right? Like, so that's one issue. But like, so anyway, so like what we did, instead of waiting for scanning at the end, right? What we started doing is we built into our pipeline. You guys know what a pipeline is? Like Jenkins. Like, so Jenkins. So every time we did a build, your smoke test went on, your unit tests, your quality, your Sonar Cube, right? I'm sure you guys probably use that too. Whatever. But what we did was we built this gauntlet tool. Now, we didn't ask for permission. We didn't need to. It was open source. We were banging away our own stuff, right? We didn't need a license from Fortify, a license from IBM. What we did is that, so the security community, we built this gauntlet tool. And it was on the Docker container. By the way, all this code is out there on the repo, by the way. Oh, you have a question?
Yeah.
Oh, sorry. So we built these scanning tools. Now, this did not negate the scanning tool at the end. We still had this. This is still something we had to do. But what we did with Gauntlet mirrored the same capabilities that were happening here with open source tooling and started running it every build, right? Every time we built, we ran it. Essentially, we were doing this. Feedback, 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 feedback. We were getting feedback every time we hit commit. Every time we did a build, that way we were able to fix. We knew everything that was coming at us before we got here. This was a formality, right? It came back with nothing because we already knew what was in there. Because that's the problem. Like we didn't get rid of this. We just made this not valuable. You understand what I'm saying? Any questions on that? No?
I got a question.
Yeah.
Does Gauntlet okay, so when we use something like a Fortify, in my opinion, it gives you a lot of jump. That not
Yeah,
necessarily
60% of false positives.
Yeah. So does Gauntlet suffer those same problems, or is it just meant to be okay? Hey, glaring vulnerability, and there's 3 of them. You know.
So we can. So I'll talk. Actually, I'll take that on next. So we'll talk about. So this all makes sense so far. I'll talk about that problem in a second. Gauntlet really addresses something called DAST, which I said was dynamic. This is the runtime. Can anybody see me online, by the way? Can you see me?
You can now.
Okay. Oh, sorry. Gauntlet addresses the runtime scan. If you guys have Web Inspect, Acunetics, the non-static code analysis, right? Your static code analysis question, I'll answer that. I'll answer that you solved that. So I highly recommend doing this. At least check out the repo. Your action item is go check out the repo online. GAUNTLT, not ET, right? You'll see James on there. The project's heating up again. If you want to get on the phone with James, let me know. We'll get on the phone, we'll talk about it, help you get started. DevOps community is community, right? It's about helping each other. It's about not working on the same code as somebody else already did. Let's advance the craft together. So I hope I'm addressing the software engineering lifecycle.
I'm waiting for it.
Oh, okay. Well, that was one of them, right? Feedback loops, right? That is one of the key things that creates the problem. Now, static code analysis, what the problem is with that. You guys use Fortify, I guess, right? Yeah, everyone does. So it's, I can pretty much say that in a 90% answer. Fortify used to be cool, kind of. Not really. So the problem with static code analysis is it creates false positives. It creates actually more work for security and app dev than it does create value, right? Literally, 60% is the average rate of false positives. That's a lot of noise, a lot of work, right? So how we got around this is, okay, the reason why you have to do this is there's a lot of legal stuff around this now. There's a lot of law, FISMA, like it's required for, like we have, so there's regulation, but UnitedHealth Group, we also have contractual based security requirements. Companies want to see special stuff, right? So way we got around this, how we solve for this is we went from oh, this is much better. Oh, this feels good. We went from static to interactive. Okay. Now, what I'm explaining by this is, so you guys familiar with bytecode, like bytecode instrumentation? So, essentially, IAST, it's a category of tools called IAST. The first ever IAST tool was created by the founder, that tall guy I showed the picture. His name's Jeff Williams. He actually lives here as well in town. But contract security, I'm not talking product. I'm just talking the fact that they're the only one that created it, the category. Essentially, what happens is instead of running static code throughout your lifecycle, instead of running static code tests, what happens is actually Contrast is an agent, a web layer agent. Okay, so what it does is, so you got a VM. Oh, you guys have VMs or real servers? Doesn't matter. Server, container, right? Whatever. Right. What happens is that the agent sits on the box, and it actually is instrumenting bytecode as it's coming across. You have to have a pretty damn good excuse if something's a false positive, because it actually saw the code fire, right? Didn't guess, right? It didn't guess what was in the letters, the syntax, right? It actually saw it fire, right? So what it does is sends that out to a team server, or just a team server, whatever. Server's all you need to know, right? It could be on-prem or it could be cloud, right? Well, what's great about all this, software engineering teams manage this, not security. Security could care less. We care less about this process. What we want is the data. And we want oversight. And we want to know you're fixing the problem, right? But what you want is, I want to be able to find my problems, identify them, and fix them in the way software engineers fix problems, right? So that is between a static code analysis and interactive. It's agent-based, like everything else is these days, right? Everything's got an agent.
You can configure these too as well to kind of reduce the noise, right? So that you don't get a lot of false positives. So let's say you identify something and say, hey, this is actually a false positive. I know some of the tools you can say, stop reporting this, right? Or put an exception in for this.
Like a good example of that would be, so you rarely have false positives with this, to be honest. But like you might have a custom parser, right? That like the contrast has never heard of, that may fire in different ways with the code. It doesn't know how to interpret that. And you can declare that as exception, that kind of thing. But like the idea, I'm not hawking this product. I'm just explaining the classification of that type of testing. I think there are some other. You got to be careful about vendors in this space. A lot of people are lying about IAST. Is that what they're doing? Is they're saying that their DAS tool, which is the dynamic thing. There's a lot of names and acronyms. This just means dynamic. They call this the star dot, AST, which is there's a static code, dynamic, interactive. So AST means application security testing. D means dynamic, right? So for DAS, all they're doing, so like HP, for example, they tried to tell me, right, that they had IAST, but I know they didn't have IAST. Right? They just put an agent on the box and called this, which is not the same thing, right? One thing is actually instrumenting the code as it comes across. Another one is scanning. If that makes sense. So, does that answer your question? I think so. It's more solution based than about the problem. But what's great about this, how you pitch this to security, is that this reduces the human requirement for testing for security. The security testing in organizations that are not DevOps oriented are doing, a person is actually, you're scheduling, you go to a scheduling site, say, I'm the I don't know, the satellite application, and I will need to do a test, right? And you schedule that. The team reaches out to you. Very human driven. Probably takes 2 or 3 weeks or more to get it scheduled. And all you do is give them a URL and account, right? And then they just hit, right? Why do you have to do that, right? Like, so another thing you can do is automate Fortify, right? So HP has created plugins for Jenkins. The problem is your Fortify has to be manageable enough. Fortify Security Center has to be manageable enough to be up to the right version to use that plugin. We ran into that problem initially. So look into the Fortify Jenkins plugin. Make sure you get an advocate on the security team. I always, if you look for an advocate, somebody in like security engineering or somebody that works with project teams in security engineering, the reason why you need an advocate, you need someone willing to create either another version of Fortify Security Center or allow you to hit it from your pipeline, right? You need to work with them on it, because what will happen is if you're a lightweight team and you're running, they're used to running, let's say you have 10 applications that got to get a lot more than that. Say you have 10. They're used to one test every couple months. You're all of a sudden going to send them hundreds per month, right? You will break Fortify if you're not careful, right? That also happened, right? At UnitedHealth Group. Does everything I said make sense? Because I see a lot of stuff.
Did anybody mention that Fortify is actually the reverse, where you ask them to come hit you instead of being able to so we kind of have that kind of license.
You mean you're running it yourself?
No, we don't. We're not allowed to run it. We asked Code 700
They're
to
running a tool, and we request them to scan or rescan based on whatever.
And then you end up with 100 or 1,000 pages of false positives.
Are you integrated with a defect management tool? What do you guys use, Jira? No Jira?
It varies.
It depends on what group.
CDCA products like Rally Dev, Rally Central.
That one.
I hate that product. I hate it. It just Rally Dev they found a way to make Agile hard, right? Like, you know what I love? It actually, I was on a podcast recently. That's how he found me again. Was the Arrested DevOps. It's with some Matt and Bridget. Anyway, we were talking about and I talking about the value of GitHub Enterprise, right? Like if you get GitHub Enterprise, I mean, you get like you guys said, great Kanban, right? I mean, that's Agile in an essence, right? It's like, Kanban is great representation to me. I'm just talking about common sense, right? Is like, I have so many intersource projects that got started United just through, pop it open a repo, start going down that. What do we need to do, right? Okay, well, we need this. We need to have this capability. We need to probably write this first and then do that, set the server, right? You just, boom, you're started. Like, you don't got to wait on the team. You don't need a project code. You don't need funding. You just pop open the project, you're rolling, right? I mean, let's self-managed team, self-organized team, self-prioritizing team. That is the way of the modern world, right? So that is that gauntlet. I'm willing to share what code I have that we used for our Docker files and to fire off Gauntlet. We also put some other configs in there, like where you couldn't declare a outside URL, which means we only allowed private addresses because we didn't want you scanning Germany or the German government. Because actually the first time, it was actually here at NASA, first time I ever ran a security scanning tool. I was in Code 300, right? And I actually was following through the tutorial guide and actually put in the IP addresses in the tutorial. It was late night, okay? And actually, I was scanning the German government. So, it's always fun to share failure stories, right? I've got a lot of those. But honestly, actually, failure is a core tenet of understanding and engineering that nobody's perfect. Shouldn't assume we're perfect. But actually, so I'll switch over to another deck for a second. Maybe I'll be a ton here. Hold on. Okay. Where do I want to go with this? Yeah, let me go with the other deck. 1 second. So let's talk about here. Right. So is failure a tool to build or a weapon to destroy? Okay, that's the question.
Dude, hold on 1 second. That's your screensaver.
Huh?
Is that your screen background?
No.
All right, okay, I was gonna say, yeah, I got the same one.
No, it's
I think you need to update your hammer.
That's me.
Oh yeah, right. Yeah. This was from I think the first store, first or second
Yeah,
one.
no, look on my screen downstairs. That's exactly my screen.
Oh,
All right,
right.
never mind. Sorry to interrupt. Go on.
So, but Odin asked Thor, right, about Mjolnir, right? It can be a weapon to build, a tool to build, or a weapon. Reality is, failure happens, right? Right? I mean, like, so did anyone here internalize this at all? I mean, did you think about this? What you would have done, right? I mean, like let's see, you're driving down in Oahu, right, on the coast, beautiful day, you know, on a Saturday, and all of a sudden, incoming ICBM, put your head between your legs in case you ask goodbye, right? Right? I mean, like, I would have been freaking out, right? I mean, this is serious stuff, right? Like, this is preventable, right? This kind of stuff is preventable. The thing is, you can't assume that what you did was perfect, right? We have to assume that we are failing, right? That failure does exist, and find ways to identify it. This is a big misnomer with chaos engineering. Because chaos engineering is often, people think, whoa, a broken system, introducing misconfiguration into the system. Well, you're not actually injecting the failure. So here's the difference, right? It's either one, you inject the failure under a controlled scenario, and the scope, you can keep the scope small, and the scale of it small. And the one thing everybody knows about, everybody knows the time it's happening, versus ignoring it, thinking it doesn't exist, and then happening when you don't know, right? Drifting into the unknown is not acceptable, right? So, in addition to that, humans need failure. We need failure to grow, to mature, right? Our systems are no different, right? So, what does this have to do with security, right? Let's talk about the problems in security in terms of data breach. Everybody loves to show this kind of stuff. Actually, my partner at RSA is like, you're going to show this again. The industry typically, so take a look at the left-hand side of this graph, right? The industry typically focuses here, right? 47% of our malicious of our data breaches every year. This data has pretty much been the same for the last 10 years. 47% of the data breaches have been caused through criminal activity, malicious activity, the Chinese, the Russians, the advanced persistent threats, anonymous, you name it, right? This is where our solutions are focused. This is where our methodologies are focused. But actually, if you really look at this, right, the other side of this story is that human error and system glitches represent 53% of the problem. That's not interesting. It's not interesting to hear about somebody's mess up, somebody's drunken code incidents, or some. I mean, come on, you guys are all had a glass of wine and go, come on. But this is where the problem is. It is arguable that many of these never would have succeeded had we solved this problem. A lot of the attacks are low-hanging fruit stuff. I mean, like, we were just at a talk on XML external entity, and that really is a low-hanging fruit. It's using old XML in a very common problem 10 years ago, right? Like, but it's the fact that like people kind of blindly go into how they approach failure. If you assume it's there, and you try to actively instrument and look for it, and that's how you get around these problems, right? So these are some examples of where failure comes in. How am I doing on time, by the way? Good?
About 20 minutes.
Okay. I'm gonna go like 10 minutes longer than asking you want me to cover questions kind of thing. I'm doing this ad hoc because I figured you guys want to cover a lot of material, and if you want me to come back, I can always come back and do some specific talk.
We set this up late Thursday night.
Yeah, yeah.
As in last night.
Yeah, I mean it's all good.
Another way of saying it, yeah.
So this is these are all areas where
we need more people to get up and present.
Well, these are all areas where security failure comes into play. Everything from bugs, misconfiguration. You know, what's funny is throughout my career as a security professional, you wouldn't believe how many times. So even at United today, right? I'll be on the morning incident call, and probably at least 2 or 3 times a week, somebody fat fingered a firewall change, right? And it brought down a portion of the data center, or you know, it's. I mean, when we talk about firewalls, I mean, we invest probably at least 160 or 70 million firewall a year, right? I mean, we spend over 450, kind of between that range on security. So, I mean, that's a lot of money, right? But firewall is a big part of it. So here's one of the things I wanted to cover. Let me see. Okay. So distributed systems can have unpredictable outcomes. So I'm getting into chaos engineering stuff, okay? Let's talk about modern software engineering. Let's talk about modern security, okay? But before I do that, I need to explain that distributed system problem again real quick. So what distributed systems essentially mean is things are no longer being all designed on one server or one thing, right? They're distributed. That's as simple as what that is. But it's gotten a little more complicated than that. Okay, so essentially, you have, let's take my UHC. This is not a real representation. I'm not giving away UnitedHealth Group. So my UHC, if you guys have UnitedHealth Group, I don't know if you do or not, but if you did, okay. It's our main interface to a lot of our products. But it's, for example, there's things like claims, there's things like payment, pharmaceuticals, eligibility, provider lookup, you're looking at new doctors or whatever in your area, kind of thing. Okay, but like, so these things are broken out into microservices, APIs, right? So you may have, I'm doing distributed, if you guys heard me earlier, it's the same thing, but that I'm talking about, but so each one of these has an API. So API, okay, right? But we do things like blue-green deployments. So for this one API down here, right, we'll run API 1, API 2, API 2, API 2, for example. Or let's actually, that's a reverse. Sorry. We'll do 1, 1, 1, then 2, right? So essentially what this means is that, do I have green? I don't have green. Oh, okay. Essentially, this means that 25% of our user base is using this new function, new feature. It could be that, think a red, green, colorblind button, right? You needed to update a button to a new color to ensure that met that need, right? So you updated it, but what you do is you use something like Console, like a service discovery tool, and what it does is you can actually focus just 25% of the volume to this one API, right? Everyone else is using the regular API, because you don't want to roll this out, right, to the rest of the user base until you know it works, right? So what I'm not going to go in depth about how to do this, right? But I can at some point. But the point of it is that this shows that you have multiple versions just using this testing methodology of one API, right? So magnify this by about 10 different versions. At any given time, we may have 3 to 4 instances running for resiliency, right? In case there's a health problem with resources and services. So for one API, we may have 30 total instances running, So 30 times 1, 2, 3, 4, 5, right? 150, right? 150 APIs running for one application, right? Not to mention we're using things like Wells Fargo for payments. That's right. We're using HHS. We have to do reportability and auditability about some of the things we do to the Department of Health and Human Services. You get what I'm going with this, right? But these things are constantly changing because of they're doing DevOps, they're doing continuous delivery, they're trying to get their cycles up to 10 times a day for delivering new capabilities and features. Because it's all about value, right? Now we're doing continuous delivery. Each one of these APIs is a team of people. They're delivering 10 times, 1 time, 3 times, 30 times, right? Like these things are just running all the time. How is it possible to know what's going on at any given point in time? It's not, right? What does documentation mean now?
State.
Right. You're on, right? So that's security in a distributed world, right? So this is a very stateless environment, right? Security is typically very production release oriented, or major release oriented, right? So we think about, security architecture gets pulled in, or engineering, or whether you have, usually there's very few of us, right? Especially very few engineering resources when it comes to security. So like, unless you're in Silicon Valley, but we're thinking about that original production release. So we're designing security for day 0, okay? So we think about, we're gonna put a firewall here, right? And that's gonna protect all of this, right? But the reality of it is that this is just an example. This is not what we really do. Like we can talk about different kinds of capabilities, but I will use firewall as a general example because most people understand what I mean when I say that, versus going to something like, external XML external entity, or like advanced configuration management capabilities, things like that. So, so what's happening though is to this day 0, everything was hunky dory. We know we're right because we know there's only 5 APIs, or so we think, right? Right. But from day 1 to day N, we are drifting into failure, or drifting into the unknown. You understand what I mean by that now, right? Is that all of these things are changing, magnified by 10, 16, remember, 150 APIs from 5, right? So there's a lack of feedback loop on security from when these things change to this thing, whether or not this is actually still effective, right? So security controls, this is where I brought the innovation to chaos engineering, is I said, well, security is ill-prepared for this problem. We think this still works, right? So, getting over here, back to my slides, right? So modern software, as I sort of showed in my example, modern software is highly distributed, stateless, right? Meaning that like if there's immediately even a 1%, 2% change in health, we just spin up a new version, right? We use immutable infrastructure, things like Terraform, cloud formations, and just, you know what, we'll figure out this problem later. We'll shift everybody over to the new app on that because it's healthy, right? And we'll figure out this problem here, right? It's iterative, right? Continuous delivery, DevOps. We're no longer delivering 6-month cycles. We're delivering functions, features, bug fixes 10 times a day. I mean, if you're a hard-hitting team, right? The changes are rapid, but also the designs are becoming super, super complex. Now, modern security, on the other hand, is still mostly monolithic. You got to call the security team versus security being distributed at the team level, or security testing instrumentation being done by a development team versus a security team. It is state dependent, right? So we're designing stateful security in a stateless world. It's still focused on being preventative, and security is also very complex. So that's that. How do you avoid drifting into the unknown? Right? I'm gonna do it all the time. I better cut here. So the thing is, you ask yourself better questions, right? This is more for security folks, but also for devs to make an argument, is that how do I know my security really works? Am I sure it really works that way? And how would I know? Like, how do you objectively know something's working, right? Is it just because, oh, Timmy designed it, he's our best firewall engineer, so it could possibly be messed up. Well, Timmy makes mistakes too. So the thing is we don't realize we made a mistake or a failure in security until there's a incident, right? But incidents is too late. What's funny is if you ever hear somebody talk about how their incident response process is proactive, incident response, like it happened already, right? You just discovered it. It could have been out there for 100 days, right? 90 days is actually our common, for a data breach, at least discovery of a data breach. It takes us 90 days after it happens. That's a general mark. Anyway, security incidents are not detective measures. And finally, hope is not a strategy. Hoping stuff works, not how you do it, right? And so what chaos engineering does, the last 1 minute summary, is that chaos engineering is, so instead of hoping that something's working, what I'm going to actually do is I'm actually going to purposely make it not work, right? Is I'm going to introduce a failure into the system, right? Just to understand, well, so you inject the failure into the system to determine whether or not it actually, your system actually respond the way you thought it did. Does that make sense? So I can really get more into that if you guys want me to spend my last few minutes talking about that, but
a control fire.
Control burn. A very similar example, our flu shot.
So just a quick question. So how is this different? So if you're doing flight software, if you're testing flight software, my job is to break your shit. Every 6 ways from Sunday, any way I can, I'm going to break it because that means that I'm better than you. So how is that different than this in terms of instrumenting the software or instrumenting the system such to capture and catch those failures before they can do catastrophic damage?
So are you talking about the social argument with like management or the cultural,
well,
trying to bring it up?
Compare and contrast that, when you're testing flight software because it's a million miles away in a toaster versus this, which is seemingly similar, but there's got to be a differential somewhere.
Yeah, so here's what you do, right? So, I mean, nobody starts off running this stuff in production, right? So there's something called a game day exercise, right? And so essentially the game day exercise, you identify your current state. You make a hypothesis about it. I'll get to your answer. So I just want to walk there. So like this exercise, so you do your planning. You plan, you build, you run, you do postmortem. A lot of people don't like postmortem and they say PIR, which is post-incident review, because nobody died. But sometimes people die. So I'm just gonna keep that. Okay. So nobody dies from chaos, and nobody's idea. Okay. But the idea is, so you plan your exercise, right? You build an experiment. So the experiment is always recommended to do it as code, because you know what happened when you did something, right? Meaning like you don't just go click on stuff. You write the code, whether it be Python or something. That way you know exactly what executed if something went wrong, right? So you build it, the experiment, you test it, right? But you start, by the way, when you build, small scope. One thing, one change, one thing, right? There's a major difference between experimentation and chaos engineering and a lot of other methodologies, is that you're not like creating thousands of changes, hundreds of changes, different levels. Like in security, there's something called red teaming. The goal of red team is to get in, so there are all kinds of changes. It's hard to filter the signal from the noise at the end and figure out whether or not you actually caught it, right? So you start small in scope, and you always start in test or dev, right? To build, so that when you go into running, you run in one target, one change, right? And because you're trying to control the blast radius, right? But you start in a lower environment to build competency and confidence that you understand what you're doing first. You understand what you think is that your assumption is true when you run the tool, right? And so you run the experiment. But when you run the game day exercise, this typically is comprised of the 2 pizza rule. I mean, you should not have more people than feed with 2 pizzas, right? Because then you get a bunch of opinions and stuff like that, right? It should be your top engineer. You have your monitoring team. Could be IT. Could be security. You don't have to go with security here if you're doing security cast engineering, but you might want definitely sort of maybe your lead app dev on the product team. Somebody understands what the reaction is going to be for the product. You don't want to do this on massive systems. Think product. Think individual app. Think one API of a 10 API system, right? And this is typically conducted for 2 hours. 2 hours. You say, I'm going to do this thing for 2 hours to the team. We're all in the room. I'm going to make this change. You guys are trying to figure out whether or not we actually did what we thought we could do, right? And then after this exercise is over, whether we succeeded or we failed, we talk about in depth. We talk about for at least 1 to 2 hours. Talk about what went wrong, right? We talk about what worked, what didn't, right? Be frank. And what's funny is the most common result of the first time somebody does this is that they say, oh, I didn't know my system worked that way. Oh, that's how it works, right? Is that people do make a lot of assumptions how things work. And that's where this is probably the most valuable part of a chaos engineering exercise, postmortem, because very few people really do this, right? This is your root cause analysis, right? Until there's a really bad problem, it's too late, right? So the idea is to eventually go from test to prod, because there's a major difference between what's running in test and dev and what runs in prod, right? The drift between those environments is major sometimes, right? Sometimes it's small, but like if a failure is going to happen, it's going to happen on prod. It's not going to happen on test because you don't really care if it happens on test, right? You care when you lose the satellite, right? Or like, oh, go ahead.
Okay.
I have a little bit of difficulty understanding how this is different than test. Is it you're saying that you are doing it on the running of the product rather than the development environment?
You run it live, on live prod. But the thing is, you don't run it on. The difference is, the difference is that you wouldn't run it on like the live instance, right? Like the more practiced way to do this is to do it with a canary, right? Where this is your actual system running, monitoring a satellite, or people are showing a dashboard of whatever the app is doing, right? Like the users are using this thing, right? You're spinning up another version of this, whether it's a containerized environment or you have something running AWS or you have your own cloud with VMs. VMs are not as good with this, but you can do it with VMs. Most people do these type of things on container-based environments because they're lightweight and they're spinning up another one. You don't lose much resources, right? But you do it on like a copy of production, and you do it there, right? That way you're not impacting the actual, you know what I mean, the actual live service.
So just to interject a little bit too as well, like for satellites and that sort of thing, you wouldn't do this, right? If you look where it was born out of, like you mentioned, Netflix.
Yep.
And what they were aiming for was that they can degrade the service without the service going down. They can detect when problems happen in production and their system be self-healing, right? So if I lost one of my third-level dependencies, does my whole site go down? Or does that one thing circuit break it off and you get a reasonable response, a degraded response, but the rest of the system stays up? And that's because of what Aaron mentioned before. You have these, when you start getting into this modern architecture, you have all these dependencies. It's hard to track how everything's working. But you don't want, because your Redis server went down 3 levels down, that your main application stops working. Because it's either it's waiting too long for that response to come back, if you have intermittent service, or the response didn't get you an error, and that error trickled all the way up your system and you didn't handle it properly. So what you would do is you would interject, say, hey, I'm going to turn that Redis server off. Now let's see if we can detect and heal from that mistake. And you do that in little instances over and over in your system, so it makes your system, your overall system, resilient to failure. You want to design your system with the thought that at any given point in time, some part of the subsystem could fail, but the overall system should not fail.
Yeah, but this is true with satellites too. I mean, like you get a bit flip somewhere and suddenly you're monitoring some value and it goes sky high and you're like, whoa, I'm not pointing at the sun anymore, or whatever it is, right?
Yeah.
So, I mean, a lot of satellites have resilience in them at the very least. Say, okay, I don't know what the heck is going on. I'm going to point my solar panels at the sun. I'm going to call home and say, please save me. Or, the equivalent, right?
I think the thing that's different is that you don't, with this, your ultimate aim is to actually have it running in production.
Right,
Various times
you
in
would
production.
not usually flip a bit on the satellite.
But you may never do that.
Well,
You cannot tell me
before it lifts off or whatever.
Yeah.
But you cannot tell me it is not valuable, even if you never did this in production ever, right? You cannot tell me it would not be valuable to know this information in stage or product, right? Not product, QA or a lower environment. You still do good valuable. It's just not exactly the same as product.
Well,
But like,
I think one of the things is that there's a presumption, at least in Goddard, that we can everything is deterministic, and we know everything that's going on. As opposed to like JPL, where they've got VMs spun up like 30 of them at a time, and all sorts of stuff is running simultaneously. It's just, it's a fun party. So in Goddard, the presumption is that we can test everything statically, and we can make everything deterministic. But you've got multiple layers of operating systems, you've got applications, you've got drivers, you've got everything. So the idea that you can know everything that's going on and test it as such is a fallacy. So getting back to the point of how do you improve the resiliency of the software by not assuming that you've tested everything and that it works the way it's going to work, even if you've got code to accommodate bad headers or bad messages or whatever. Because the presumption is that we don't really build that resiliency into our software today. Because we think we
so can I say one thing to what you're saying? So like incidents and failures, when we determine them, we find them out. A lot of times, the deterministic thing you're talking about, right, is that like the way in which incidents happen are subjective, right? You do things in preparation to unknown event types or the failure modes, right? You assume what you have in place and can detect those things, right? Like, but how do you know? This is what we don't do. We often determine that incidents were caused by direct events, which is rarely ever true, right? Incidents often are actually caused by things like the butterfly effect, right? Is that these things were connected. Incident was caused here, right? This could be an external thing, right? Could be a dependency on another system, right? But a combination of things caused this thing to happen, and this is typically the far furthest we can go, right? Like, the thing is that all of our measures are somewhat like subjective. The only way to actually find out whether or not it worked was to cause a controlled event. To find out, like from beginning to end, did it work? Right? Did this failure mode, were we actually able to detect it? What this does, it turns the subjectivity into objective. Is that we can measure now. Because we caused the event, we can measure how long it took, right? Like what kinds of failure modes we're good at, what kinds of data we didn't have, right? What kind of data we should have had, right? How valuable the data from certain systems that we didn't think were that valuable were actually more valuable than we thought. Like, or the investments we made in a certain technology are paying off, right? Or maybe that code we wrote is better than that $30 million product we bought. Anyway, like it's the same sort of concept, is that cascading failure is rarely ever accounted for. So, thank you all for having me out here. Sorry I said a lot of things. I'll put my contact info back up here. So if you guys want to reach out, just let me.
Send me the slides out. I usually put out some notes afterwards, and I'll include it.
Cool.
This actually, real quick before you guys go, we're going to try to line up a bunch of security related talks. So I've invited our security people like 2 years straight. Can talk to us, and they always and they kind of like turn to another subject or whatever. But so we're going to try to get some external security people and compliance people, because I just found out there are 2 different types of people. Yeah, I did not know. I was talking to my compliance person about security, and that person did not get it. And she was like, just fill out this paperwork.
You're lying now.
No, I get it now. Her job is important. It is important. I just misunderstood the difference between compliance and security. They're two different things. But we're going to try to see if we can get some of both. There's automatic compliance tools out there that we can look at as well, so that you're not just shuffling papers. And as you're moving from that dynamic environment, you can still satisfy the compliance people, which are just paperwork people, right? Because if you don't, they're the ones there when you say, "Hey, security, can we do this thing?" It's not security that says no. Security people usually say, "How did you do that securely? How do we make this secure?" It's the compliance people that says that's not in the paperwork. You can't. Right? But trying to ignore them does not help. You gotta work with them, bring them into the modern age. But we'll try to bring more of those people in. If you guys have other ideas, let me know. Please, 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 if someone is willing to help, because I think very, very, very shortly, like I said, my role is gonna be changing. I'm gonna have less time than I had before, and I don't want the group to die because I'm not here. All right. Thanks everybody. Come out. Please sign the sign-in sheet and take pizza.
I'll leave this thing, right?
Yeah.
Nobody signed it. I don't think anybody signed it.
No, there's another one floating around.
Oh, okay.
Sorry. One, do you have any family in Western Pennsylvania that works with carnivals? Seriously.
I might. You're gonna be at the Rinehart?
Yeah.
Like it's